Welcome to day 41 in our HiSET learning pack. Today we're going to be working still with triangles and a special rule that we use with triangles, which I'll get to in a little bit. But first, on to our math windows. Okay, let's see what they have for us today. First one. What is the probability of getting an odd number when rolling a single six-sided die? So a die, un dado, a die has six sides to it. A number 1, 2 dots, 3 dots, 4 dots, 5 dots, and 6 dots. So the odd ones would be 1, 3, and 5. The evens are 2, 4, and 6. So you can see right away that half of them are odds. So the probability of getting an odd number would be 1/2. Or you might have said there's 3 odds, 1, 3, and 5, and there's 6 numbers altogether, 3/6. But 3/6 is equal to 1/2. You would just divide the top and the bottom both by 3. You can convert fractions by multiplying or dividing the numerator and the denominator by the same number. 3/6 is equal to 1/2. What is the probability of choosing a jack or queen from a standard deck of 52 playing cards? Well, if you've ever played cards, you know that there's 52 cards in a deck. There's 4 suits, diamonds, hearts, clubs, and spades. And there's a jack and a queen in each suit. So there's 4 jacks and 4 queens. So that means there's 8 jacks and queens out of the 52 cards. You might also know, if you play enough, that each suit has 13 cards. There's 4 suits, like we said, and each one has 13 cards, going from 2 up to 10, and then jack, queen, king, ace, 4 more to the 9. So that makes 13. And 2 of those, jack and queen, is 2 of the 13. Either way you did it, you come out with the same answer, because 8 52seconds is equal to 2/13. You divide the numerator and the denominator by 4, and you get 2/13. 2/13, if you had put this in your calculator, you would have gotten 2/13 is 0.15. It would round to 0.15. Any of these answers you might see in a multiple choice. Usually not this one, because it's a fraction that's not reduced. You might see fractional form, or you might see this. Or they might even say 15%, because 0.15 is the same as 15%. Those are similar answers. Okay, on down to number 3. Talking of percent, here we have a percent problem. What percent of 38 is 15? So 15 is part of 38. 15/38. If you put that in your calculator, you will get, it will round to about 2.5. Wait, 0.39. Sorry, 0.39. Right? That's a decimal. To change that to a percent, they want percent. This is 39 hundredths, and percent is hundredths. So you want to move the decimal point 2 places. That's equal to 39%. 4% of 73 is what? Again, I should remind you, if you remember how to do these, try to do them by yourself first. Only give the solutions if you're having trouble remembering how to do something. Okay, 4% of 73. I always say the word of is a clue that you're multiplying. 4% times 73, but we don't multiply by percent. We change it to a decimal. So you go the other way. You move the decimal point 2 places. 1, 2. You end up with 0.04. This is 4 hundredths. Remember, percent is hundredths. 4 hundredths. This is 4 hundredths written as a decimal. Times 73. If you put that in your calculator, you get 2.92. Now, does that make sense? Let's see. 4% is about a 25th. So if you divide that by 25, goes in there about 2 times, almost 3. Yep, that sounds like it's very close to what would be the right answer, 2.92. Okay, so we're going to move on here from our math windows. And this is the topic today, Pythagorean relationships. Pythagorean relationships. Okay, sounds like a big name, but I guess it's some Greek thing. A Greek who discovered that when you have a right triangle, now this only applies to right triangles, that if you measure the legs, those shorter legs, now the legs are the part that connect with the perpendicular, that form the perpendicular. Those are the smaller sides, the legs. If you measure each leg and you square this leg, square means you multiply it times itself, and you square this leg, you multiply it times itself. You add those two together, and it's equal to the hypotenuse squared when you multiply this one times itself. So these two smaller ones, you square them, add them together, and it's equal to this one squared. Sometimes they say it as A, B, and C. And the rule is A squared plus B squared equals C squared. Okay? A and B must be the legs, though, the shorter sides, and you can tell because they form the perpendicular. Okay, read through this anyway. Read through it and make sure, because it does a good job of explaining better than me. Read through it, and remember, this only applies to right triangles, triangles that have a 90-degree angle. And here they show you the A squared, B squared, C squared, and they give you an example down here. And this is actually a pretty famous, probably the most famous of the right triangles. Now, you could have any number here. You could have any decimal numbers. They often don't come out with nice round numbers. But there's one special one, this one here. If you square 3, you get 9. You square 4, you get 16. 9 and 16 is equal to 25. So we know that this side squared is 25. What number squared is 25? 5. This one would be 5. And this is a famous right triangle because it has nice round numbers, no decimals. It's called a 3, 4, 5 right triangle. That's an important one to learn because you see that a lot of times when they give you problems, they don't want to deal with decimals, so they'll give you nice round numbers. Well, 3, 4, 5 is the most common, not the most common, but the most famous of all the right triangles. Now you could take this 3, 4, 5. Let me write it down here. You could have a 3, 4, 5 triangle, right? 3, 4, they're the legs, and the hypotenuse would be 5, right? If you multiply these by 2, you end up with a 6, 8, 10 triangle. And it's the same as this one, it's just bigger. So this also should work. And in fact, 6 squared is 36, 8 squared is 64. If you add them together, you get 100. That's 10 squared. You could do 3 times this. 9, 12, 15. This is also 1 because it's it's the same as a 3, 4, 5, just multiplied by 3. You could do any factor times these numbers and come up with a right triangle with nice numbers. Okay, and there's at least a couple other famous right triangles, not as famous as 3, 4, 5, where they work out pretty easy, and we'll try finding some of those as we go along. Okay. Anyway, read through these pages of explanations. You get a word problem here, and this will give you an example of how you might use the Pythagorean Theorem. You might use it this way. In this problem, there's a ladder placed against the wall. It tells you how long the ladder is, and it tells you how far away you place the ladder, and you have to figure out how high up on the wall you can get. Now, in this one, here's the right angle. So this is the leg, this one and this one. In this problem, you're finding the missing leg. So you will square the hypotenuse and subtract this squared. And that won't give you that number. It'll give you the square of that number. So in some of our problems, we're going to have to find the square root of a number. The square root is the opposite of finding the square. Instead of multiplying the number times itself, you want to find the number which, when multiplied by itself, makes the starting number. Okay. Anyway, read through this. You can see in this example, they come out with a not such nice answer, 12.6. Okay, so we're going to go on to the problems now. So now I'm going to the Pythagorean relationship practice, page 9 of 13 on day 41. Okay. The lengths of two sides of a right triangle are given. Find the length of the remaining side to the nearest 10th unit. You may use a calculator. Well, thank you. I don't know what I would do if I couldn't use a calculator on this. This would be... It's not that easy to find the square root of a number if you don't have a calculator. You have to just guess. Well, I imagine you have to just keep guessing and getting closer and closer, multiplying them out until you find the right number or the closest number. Okay, leg 8, leg 8. What do you do? So those are the legs, the shorter side. So you square 8, 64. Another 64. You add them together, 128. Does that mean the hypotenuse is 128? No. The hypotenuse squared is 128. So how do you get the hypotenuse then? You have to take the square root of 128. Now I'm going to show you how to do that on my calculator, my phone calculator here. So I go to my, let's see, where am I? That's not right. How did I do that? I hate these things. I go to my calculator. Okay, and I got to clear it, right? Clear it. Okay, so I want the square root. Now, when I was trying this today, I couldn't find the square root, and I realized, oh, there's this little arrow here. So I'm going to pull that over. There's the square root sign. That thing right there. That looks like a division sign. Can you see it there good? Looks like a division sign. That's the square root. So I'm going to push that first. Square root. Did I do that? Oh, I did. Oh, yeah, I'm sorry. I got two of them now. Got to get rid of one of them. And it's what? 128 we said? 128 is 11.3. Is that correct? 11.3. 11.3. That makes sense because if the two smaller sides are both 8, the larger side, the hypotenuse is 11.3. Okay, so that's how we're going to be doing these, okay? Number 2, you got a leg of 9 and a leg of 12. Let's see if we're in the right place. Oh, boy. Here we are. A leg of 9 and a leg of 12. Now, my trained eye, I look at that and I say, they're both divisible by 3. 3 into 9 goes 3. 3 into 12 goes 4. Ah, it's a 3, 4, 5 right triangle. 3, 4, 5. So if that's multiplied by 3, I'm going to multiply 5 by 3 and get 15. It's the same as a 3, 4, 5. It's just multiplied by 3. But if you don't remember that or you don't recognize it, you could do 9 squared is 81. 12 squared, if you put it in, is 144. You add the two of them together, and you get 225. Use your square root function. Square root of 225 is 15. Okay, number 3, 1.5 and 2. Well, you put these in your calculator. 1.5 squared is 2.25. 2 squared is 4. Add them together, you get 6.25. Take the square root of 6.25 and it comes out to be 2.5. This actually is also a 3, 4, 5. Because 5 goes into 15, 3. 5 goes into 2, 4. 5. 5 into 25 is 5. This is a 3, 4, 5 also. Anyway, 2.5 using your calculator. Number 4. over here. So here, they're missing a leg. So what do? You square the hypotenuse, 36, and you subtract 3 squared, which is 9. That gives you 27. So this squared is 27, so you have to take the square root of 27. If you put that in your calculator, it should come out around 5.2. Missing leg again. So again, you're going to square the hypotenuse and subtract. 10 squared is 100, minus 6 squared is 36. That comes out to 64. If you put the square root of 64, it comes out what? 8. This is a 3, 4, 5 triangle multiplied by 2. 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. 5, 18. Okay. 18 squared. You put that in your calculator and you subtract 5 squared, which is 25. And you take the square root of that, and it should come out to be about 17.3. Using your calculator to figure that one out. Okay, number 7. Again, square 7. Here you have the 2 legs, so you're going to square them and add them. That's 100. That's 49. 149. You want the square root of 149. Putting that in your calculator, you should be practicing doing these in your calculator so you're confident when you take the test how to use your calculator. 15, 30. Hypotenuse they gave you, so again you're going to have to subtract because you want the other leg. 30 squared is 900 minus 225. And then you take the square root of that. What did I come up with? I came up with 25.98. But if you round this, that's going to go up. That's going to go up. It becomes 26.0 if you round it. Or 26. 4, 5, 7. Oh no, that's a question mark. This is not a 3, 4, 5. This is a 4, 5 and a bigger number. So you got to square it. 16, 25, 41. You want the square root of 41. And that comes out to about 6.4. Okay. I don't even know if you're seeing these. Okay, there it is. Okay, so we're going to move on down to word problems. I always like to do word problems, right? So here's points on a coordinate plane. On a coordinate plane, points A, B, and C can connect to form a right triangle. If you connect them, you got a line going this way, horizontal line, and then a vertical line. They make a perpendicular. And if you connect these two, well, you got this slanted line. Now, if this was a right triangle, it is a right triangle. These are the legs because they form the perpendicular. The long one is the hypotenuse. What is the distance from A to C? They want the hypotenuse to the nearest 10th units. Okay, if that's the hypotenuse and these are the legs, you have to square the legs. 1, 2, 3, 4, 5, 6. 6 squared is 36. 1, 2, 3. 3 squared is 9. You add them together, 45. And you want to take the square of 45. If you put that in your calculator, where am I? Came up with 6.7. There it is, B, 6.7. Number 11. Two shorter sides of a right triangle measure 18 and 24. What is the measured feet of the third side? Well, look, I know it from my multiplication facts that those are both divisible by 6. 6 times 3 is 18. 6 times 4 is 24. So that's a 3, 4. So we're going to multiply 6 times 5 to get the other one. 6 times 5 is 30. Now, you could have put this in your calculator. 18 squared plus 24 squared. You add them, you take the square root of that number, and it should come out to be 30. Number 12. Jan has built a rectangular frame out of wood to use the bottom of a platform. He wants to add a diagonal base as shown in the drawing below. Okay, he wants to put a brace here so it stays together better. Okay, he's got this side is 5 and this side is 11. What's this side? 5 squared is 25. This is a right triangle because you usually build things like this with the right angle. 11 squared, if you put that in your calculator, 121. You add them together and you get 146. This squared is 146, so you want the square root of 146. Now I know the square root of 144 is 12, so the square root of 146 must be a little bit bigger. But if I put it in my calculator, I come out with 12.1, just a tiny bit bigger. Last one. The hypotenuse of a right triangle measures 39 inches. If one leg measures 15 inches, what is the measure of the other leg? So the hypotenuse is 39, then one is 15. What is the other one? So you square 39. Square 39, and you square 15, and you subtract that from the square of 39. But you know, this one, I know if I divide by 3, I get 13 by 5. And this is another one of the right triangles that works. A 5, 12, 13. 5, 12, 13 works. So this is 3 times 5, 3 times 13, 3 times 12 should be 36. But if you did it in your calculator, you'll get the square root of some big number, and that's 36. Okay. Moving on. Now for some real tedious work. Oh, this is interesting. Do the following lengths form a right triangle? Well, 6, 8, 9. Well, 6 divided by 2 is 3. 8 divided by 2 is 4. So if this was a right triangle, it would be a 3, 4, 5. 5 times 2 is 10. This is 9. Anyway, if you put this in your calculator, 6 squared, 36. 8 squared is 64. You add them, you get 100. The square root of 100 is 10, not 9. So this one is no, not a right triangle. Number 2 over here. How about this one? 5, 12, 13. Isn't that the one we did on the other page? We said is one of the famous easy right triangles. 25, 144. You remember you square them. Add them, you get 169. What's 13 squared? 169. This is a yes. 6, 8, 10. If you divide by 2, you get 3, 4, 5. Yes, this is a 3, 4, 5 related triangle. You could put it in your calculator. And did I even show that one? I don't think I did I? No. This was, I divided by 2s and I got 3, 4, 5. So yes, it is one, but you could put them in. Number 4. This one says 3, 4, 5. Well, you better know that one by now. That's yes. Here they just gave you numbers. 6.4, 12, 12.2. Well, this one's really close to this one, but this number is pretty big. I don't know. If you squared them and put them in, you would get 41.6 for this one. And this one is 144. And this one is 148.8. If you square them. 41 and 144 is way bigger than 148. This one's no. How about this one? Well, if you put them in, you end up with What did I end up with this one? 4.41 plus 51.8. I added and I came up with like 56.21. Now if you put 7.5 in, you get 56.25. And I figured they're close enough. They're close enough, so this is a yes. Again, using your calculator to figure those out. Okay, so now we go on to a bunch of these. Find the missing length. How are you going to do it? Well, you square. 4 squared is 16. 8 squared is 64. You add them together, you get 80. And then you take the square root of 80. I got 8.94. And I'm going to do one more here. So you got 6 squared is 36. 3 squared is 9. You add them, you get 45. Square root of 45. What did I get? By the way, I'm not figuring this part out in my head. This part I had to do before with the calculator because square roots, like I said, are really hard to figure out. You have to just keep trial and error if you don't have a calculator. 6.7. Okay, 6.7. Anyway, these are all the same. If you want to do them, you can. But if you're pretty confident you know how to do Pythagorean Theorem, then you don't have to work through all these. It goes on and on. The thing to remember, though, is what are you looking for? You're looking for the hypotenuse. You're looking for the hypotenuse. I'm sorry, hypotenuse. The hypotenuse is missing. Now, when you get down here, look, it's one of the legs. So this time you're going to have to square and subtract. This one, again, it's one of the legs, square and subtract. So you have to know when you're subtracting and when you're adding. If you're looking for the hypotenuse, you add. But when you're looking for a leg, like this one, because the legs form the perpendicular, you must subtract the squares. Here you're missing a leg, so you have to subtract. Anyway, you can do those for practice and see how far you're going to get. See if you're able to do it. Again, if you're able to do it and you're sure of what you're doing, you don't have to do all these. That's only up to you. You decide how much you need to practice. We're going to do the last page on a separate video because this is getting a little too long. The last page isn't even about the Pythagorean theorem. It's just word problems and practice problems with fractions and decimals. I guess they just want to make sure you remember some of those things. So we'll do that on the next video.